So we're going to talk about baby boomers, and baby boomers in the United States were generated as a result of a significant spike in the birth rate that happened between the years 1946 and 1964. It's convenient; it's the same numbers, just reversed. Let me check the next slide. As a result of the baby boomers, one of the things that's beginning to happen is a major increase in the number of retirees, and that number, just to give you a quantification, is expected to be over 50 million in the United States by the year 2020. So who are these boomers? Well, it's important to remember that when they came of age, when they or we came of age in the 1960s and 70s, they were both veterans and protesters of the Vietnam War. They ended up having more college degrees than any prior generation. Politically, they were both protesters and traditionalists, and often referred to as freedom seekers from a variety of perspectives, only some of which are listed. Let's meet a few of these baby boomers so you can get an idea of what we're talking about. Here's the kind of transportation systems that were all too common in those days. Here's an example of some of the politically active baby boomers in the 1960s. Here's another collection of same. Here's what some of these baby boomers look like in the current day. And then last but certainly not least, here is an example of how some people managed to spend their time in the second half of the 1960s and early part of the 1970s, operating a console of an IBM 360 computer system, in case people don't already remember that. So what happened to this IBM 360 operator? Well, at some point, it's very likely that he got a degree in something other than computer science, because there weren't that many computer science departments even in the 1960s. Likely had degrees in something like math or psychology or physics or sometimes English. Managed to learn a programming language. Could be Fortran, could be COBOL, could be assembler, to get a programming job at an organization, and you could typically find this organization based upon it being an organization that was large enough to be able to afford their own IBM 360 computer, or by the 1970s, large mini computers that were being used as well. And so this same character began writing enterprise applications probably in the 1970s, and certainly by the early 1980s. If you look at these enterprise developers today, they've played a key role in the development of 10 to 15 applications or systems within one or more organizations. Most of these systems were built on an overly aggressive schedule, and they were never well tested nor well documented. Languages that might have been used in the 1970s would have been Fortran, C, not C++ in the 70s, COBOL. Later on came languages like C++ and Java and Smalltalk and Ada and APL and Pascal and Objective-C. And many of these developers are actually still involved directly or indirectly in maintaining these systems that were built in this time frame. So how much code might that individual IBM 360 operator that became an enterprise developer have been responsible for? Well, a single person working without much distraction can generate 10,000 lines of code per year. A lot less if you don't care whether it works. A lot more if you don't care whether it works or not. So if that's the case, then between 1968 and 2008, that single individual could easily generate 400,000 lines of code. And the programmer, which is a likely situation, if this programmer started supervising even just a team of 5 developers, then it's easily imaginable that single team might now have generated 20 million lines of code. So how much is 20 million lines of code? Well, a rough estimate is that what you're looking at is about 200 boxes of computer printout. And of course, in the very early days, these were gigantic printers that were almost 5 feet high and were incredibly unreliable. We thought of them as being amazingly fast at the time. Huge mechanical monsters that were quite challenging to deal with. But let's look at what this single boomer programmer could have done if they generated 20 million lines of code. It would cost about $60 million in today's dollars to generate that amount of code, and it would take at least a half a decade or more to develop this quantity of code. And who are the users or beneficiaries of this code? Well, the answer is the enterprise and its customers. And it's easily the case, likely the case even, that this code is actually critical to the successful operation of a multi-billion-dollar enterprise. Here's some actual examples that I have run upon in my career. One is ran into a single program through which every single product in a $5 billion business flowed, and it turned out that software was written by one individual, only understood by one individual, and was being maintained by a single individual. I've also seen a set of programs required for the operation of hundreds of large-scale medical centers developed and maintained by a single individual, and a programming environment on which a multi-billion-dollar fixed income business was completely dependent. This was, a special purpose programming language built in a very, very esoteric fashion around which a multi-billion-dollar business was absolutely critically dependent. Boomers can't last forever. There's going to come a time, and it's not that far away, in which these boomers simply become unavailable. And so what's going to happen within the organization once that happens? Somebody is going to have to figure out how to maintain that legacy code. Somebody might have to figure out how to re-engineer the code using modern languages, architectures, and tools. And a number of people will certainly expend time and effort trying to figure out if there's a commercial solution that can simply be purchased and migrated to. And there might be a fringe element within the organization that sits down and says, my goodness, wonder if we could, if we need to just simply start over from scratch in building this application or re-engineering this application. Here's what some of these systems look like. This attractive young lady in their dress that has lots of patches on it. It reflects lots of code that's poorly documented, inflexible, costly, and difficult to maintain, and not well suited to changing business needs. But the code is tailored to the business, more or less. It's certainly used throughout the organization, and it's often the case that it's esoteric enough or custom